Good afternoon. Let's get this started. Thanks for joining us for a look ahead at the upcoming 2012-2013 winter weather season. I'm Dave Vandenhavel and lead WDT's new WeatherOps division. WeatherOps is powered by Weather Decision Technologies, one of the United States' most powerful weather companies, combining the expertise of some of the country's most talented weather forecasters with technologies of a global weather company and software leader. WeatherOps offers the most compelling solution for the world's Fortune 100 companies and small to mid-sized businesses concerned with safety, asset protection, and their bottom line. Our dedicated team of meteorologists provides support to your operations 24/7, 365. Our slogan is, "We watch the weather while you take care of business." Our team is enhancing our suite of products and services with decision aids and forecast guidance, including custom weather triggers for key criteria within your business. This is information that you can trust. Over this past summer, we helped save lives and protect property during hundreds of outdoor concert events and festivals around the globe. We are also creating new products and services for the upcoming winter season. Before we talk about these new products and services, let's take a look ahead at the upcoming winter weather season. I'd like to introduce you to Jason Anderson. Jason is one of WeatherOps' senior meteorologists. He's a winter weather expert. He grew up in upstate New York and graduated from the State University of New York. He has over 12 years of winter weather forecasting experience and brings a great deal of experience to the WeatherOps forecasting team. Jason, why don't you describe to us what this upcoming winter season is going to look like?
Thank you very much, Dave. Welcome everyone to this WeatherOps Outlook for the winter for 2012-2013. Before we get into the upcoming outlook for the upcoming winter season, I thought it would be interesting to go back and look at what happened last winter season to use that to inform us for what's going to occur for the upcoming season. The winter of 2011 and 2012 was historic, but not historic in the way we normally think of a winter season. Normally, winters are historic for their cold, the heavy snow, or major ice storms. Last winter was historic because absolutely none of that occurred. In fact, it was the exact opposite. It was extremely dry and very, very warm. So, what happened last season? What caused that, and how can that inform us going forward into this upcoming winter season? One of the major influences of the last winter was La Nina. For those of you unfamiliar with the term, La Nina is a term associated with the abnormal cooling of the eastern Pacific waters, typically off of South America. El Nino is the inverse of this, an abnormal warming above average of the eastern Pacific waters off of South America. Because of La Nina, it created a very strong high-pressure ridge across the western two-thirds of the United States last year, with a very weak low-pressure trough associated around the Great Lakes region. Both of these caused an abnormal change in the weather patterns across the United States last year. In addition to La Nina, another effect that caused a strange global pattern across the United States last year was the North American Oscillation. The North American Oscillation helps to explain the air mass across North America, and the oscillation is a shift or movement in that air mass due to a change in the global weather pattern. The global weather pattern was changed last year due to La Nina. And due to this, the North American Oscillation was put into a slightly neutral to positive territory through the winter season. This typically allows for much warmer air across the United States and faster-moving storm systems. While the faster-moving storm systems did greatly contribute to the drier conditions seen last winter, it was not the major driver of the warm air across the United States. A third influence, known as the Arctic Oscillation, it helps to describe the Arctic air mass across the Arctic, was in a strong to near record positive territory. As this chart in front of you shows, you can see a very solid white line across the western Pacific moving into Canada, across the border of the United States and Canada. This acted as a very strong wall, keeping very, very cold air that we typically see during the winter season locked across Canada and Alaska, and allowed for near record warmth across the United States. In fact, that warmth allowed for the fourth warmest winter on U.S. record. These records go back almost 150 to 175 years in certain parts of the country, and this was the fourth warmest winter on record. In addition to that warmth, we had near record dryness across the country as well. As this chart in front of you shows, except for a couple parts of the southern plains and areas of Arkansas and areas of the southern Ohio Valley, most of the country was very, very drier than normal. So, we had a very record warm and record dry winter last year. What were the consequences of that across the country? Well, even before that winter occurred, that fall of 2011, we already had drought occurring across the central plains. This winter only magnified that effect across the country. As this current chart shows you, currently 2/3 of the United States is in exceptional drought or becoming extreme to exceptional drought. While this is centered across the central plains, this is stretched westward across the Rockies toward the western coast. It's now going into the Ohio River Valley, toward the Mississippi, and it's also becoming a problem in southeastern Georgia and areas near Atlanta and Mississippi. Due to the lack of moisture last winter and cold air, we've had near amazing effects across the country. Lakes across the country that major cities require for water are going completely dry. The Mississippi River is going dry in some spots. Barges cannot get upstream. Dust storms have completely engulfed areas of the southwestern United States, such as Phoenix. Mosquito populations and other insects did not have their normal cycle of die-off or hibernation. Instead, they kept right on growing through the winter season and into the springtime. This has allowed for a near-record outbreak of West Nile and other diseases across the country. The center image here is Lake Powell in the western half of the country. This lake provides water for many of the major cities. It is now 50% below average and continues to drop. Wildfires are becoming a major concern across the country. Crops are either not growing or are dying on the vine. This is causing a major rise in food prices across the country and issues with gasoline due to ethanol. Again, with the insects, we've had pine beetles explode in populations in both the east and the west, and entire forests are being destroyed. And we also have it affecting fracking operations. This all ties back to what occurred last winter. So, we've taken a quick look at what happened last winter and the consequences of that. But what is going to happen for this upcoming winter season? Well, let's take a look at what we need to examine in order to make that determination. Just as La Nina was a major influence for the pattern of last winter, the opposite, El Nino, has been anticipated to be a major influence of the upcoming winter season. For the last 9 months, all major predictors have said we are going to have a moderate to strong El Nino developing for this upcoming winter season. However, as the chart in front of you shows, as of early October, El Nino has yet to form. As you see in this chart, we're seeing either near average or slightly below average temperatures in the waters of the eastern Pacific. El Nino is a warming, typically of about at least a half, if not more than a degree Celsius of warming across this region. So, at this time, we still believe El Nino will be an influence, but probably not until the very late winter season, beginning somewhere January further on. So if it's not going to set up the pattern for the winter season, what will? I'd like to introduce to you another oscillation, the Pacific Decadal Oscillation. As this chart in front of you shows, this chart is showing sea surface temperatures of the Pacific waters. You can see along the equator, the region where we typically expect El Nino, those average to slightly below average temperatures I had just mentioned. However, look off to the northwest, from about Japan going north and east into the northern Pacific. Waters out here are currently between 2.5 to 5 degrees Celsius above normal. This is very historic, actually. This is actually going to greatly influence the Pacific Decadal Oscillation, creating a very strong high-pressure ridge across the northern Pacific. And this will have an effect for the United States further downstream as we move into the winter season. This should set up our pattern for the upcoming winter season. However, of course, if we have winter, we need to know where's the cold air. We won't have winter activity if we don't have cold air, as we saw last winter. For that, we need to look at the North American and Arctic oscillations. The two charts you see on this slide show the relationship of these oscillations for the last 20 years or so. And as you can see, they're all often very in sync. When one's positive, the other's positive. When one's negative, the other's negative. As you can see toward the end of both of these charts, both of them were very negative for the 2010 season when we had those record snowstorms across much of the country, from D.C., New England, back west, and we had record cold air that year as well. Both were moving toward the positive territory last year, and that helped to contribute to the near record warmth and dryness across the country. Current weather models do not allow us to accurately predict either of these oscillations beyond about a 2 to 3 week period. However, looking at the charts that are in front of us and the current models, it looks like we are moving toward a slightly negative phase for both of these oscillations for the upcoming season. This should allow for more outbreaks of cold air for the upcoming winter, probably focused mainly along the central plains in the eastern United States. So, taking all of this information into account, this is WeatherOps' current projected outlook for the general winter pattern for the upcoming winter season. We currently expect a low-pressure trough to develop across the Rockies of the western United States with a strong high-pressure ridge across the eastern two-thirds of the country. This will allow for many storm systems to come in east of Seattle across the Pacific Northwest, right across the Sierras, travel across north to north-central Arizona and New Mexico, and then to travel northeastward across the Central Plains. The strong high-pressure ridge will allow for most of these storm systems to ride north of the Great Lakes, with some of them probably coming back down across New England. For temperatures, due to the very warm winter we had last year, very warm summer, and generally pretty warm early fall that we're seeing right now, and due to the fact that the North American and Arctic oscillations are only expected to be slightly negative for the upcoming season, we expect generally above normal temperatures for about two-thirds of the nation. Part of this is due to those oscillations only being in the slightly negative territory, and also due to the very strong ridge we expect to develop over the eastern two-thirds of the country. However, and I want to stress this very clearly, while we are predicting above normal temperatures, this will be the calculated average for the end of the winter season. It will not be anywhere near as warm as last winter. We still expect a lot more cold air and a lot more cold air outbreaks for the upcoming season. But generally, we will probably see slightly above normal temperatures by the time the winter season comes to an end. In terms of moisture, our current projected outlook is that the Pacific Northwest region, Washington State, Oregon, Northern California, and parts of Idaho will probably see below normal precipitation for the upcoming winter season. This will be due to the low-pressure trough to the east that will be pulling much of the moisture away from this area, but also due to the strong high-pressure ridge we expect to develop over the north-central Pacific that will probably dry this region out. However, we do anticipate above normal precipitation for parts of southern and central Texas going eastward across the Gulf states, and probably up into parts of the Carolinas. However, this above normal precipitation may not develop until at earliest January. This would be due to the upcoming developing El Nino. Because El Nino is lagging behind, it probably will not allow for this increased moisture until at least January at the earliest. So, I've given you a very generalized information of the pattern for the upcoming winter season, temperatures, and moisture. But many of you want to know, what does this mean to me? How is this going to affect my business? How is this going to impact my clients? How is this going to impact my assets? Am I going to see heavy snow, heavy ice? No? Yes? What is this going to mean for me? What I've done is I've broken the country up into 4 regions, and I'm going to try to walk you through each of those regions and explain to you what we anticipate is going to happen for those regions for the upcoming winter season. So, we'll begin with the West Coast and the Rockies. As I just mentioned very briefly ago, probably below average rain and snow is expected for states of Washington, Oregon, western Idaho, far western Montana, and north to north-central California. And this is due to the influence of the strong high-pressure ridge over the Pacific and the fact that many of the storm systems are going to pass east of there. To the east, across most of Montana and Wyoming, about average rain and snow for these areas for this time of year. This will be due to the storm systems coming across the Rockies. To the south, slightly above average rain and snow. And we think this because we'll be seeing those storm systems coming through this area, but they should be getting a bit of an El Nino influence for the second half of the season, and that should increase their potential for rain and snow across this area. And to the south of that, probably slightly above average rain, again due to El Nino. I want to also stress here, in the slightly above average rain and snow area, El Nino, while it does provide moisture, that moisture tends to also come with warmer air. So in this area of slightly above average rain and snow for this region, and as we go across the country, this is the area of the country that could quite strongly see a strong chance of ice storms. You'll have warm and cold air masses clashing. Depending on who wins, you could see a mix of rain changing to ice, changing to snow, or in reverse. Central Plains, a similar picture. Slightly above average rain for western Texas and parts of New Mexico. To the east, greater than average rain due to our developing El Nino for the second half of the season. To the north, slightly above average rain and snow, Colorado, parts of southwestern Kansas, Oklahoma, and eastward into Arkansas. And again, this is the area that will have to be watched very closely for the upcoming winter season. Clashing air masses of cold and warm air. If you have a storm system in place, have a strong chance of a good ice storm, perhaps rain changing to ice, later to snow. These usually tend to be very big disruptors. To the north of that, probably about average rain and snow as those storm systems will start to lift due to the ridge. Those will cause about average snow because as they get away from the El Nino source, their moisture source will go away. Looking at the Great Lakes region, most of this region is going to see about average rain and snowfall for the upcoming winter season. Because of the high pressure ridge, many of the storm systems are actually going to pass just north of this area. However, due to the Great Lakes, you will have these storm systems passing to the north, will create a west-northwest flow across the Great Lakes. This will begin to start up the lake effect snow engine. In fact, we're already beginning to see this occur here even in October. Even in actually late September, parts of western Pennsylvania, western New York, and Ohio are seeing lake effect. But it's not snow, it's lake effect rain. But once that cold air gets into place, all of that will change over to snow, and that should allow for most of average rain and snowfall across this area for the upcoming season. To the south again, slightly above average rain and snow due to our El Nino influence. That would be areas of, say, Nashville, around Tennessee, maybe parts of southern Kentucky, and then we start looking at parts of southern West Virginia, western North Carolina, and central Virginia. And then greater than average rain for the south, Mississippi, Alabama, Florida, Georgia, probably South Carolina, eastern North Carolina, and maybe far southeastern Virginia. Between these two influences, we start to see a slightly below average snow, and I say that because due to the west, as you can also see on this slide, we do have a narrow ribbon of slightly below average snow, and I'll explain that further in the next slide. Our final slide takes us to the east coast and the northeast. Again, to the south, parts of Georgia, South Carolina, eastern North Carolina. Slightly above average rain, again due to the El Nino influence. To the north, central and western North Carolina, central Virginia, and parts of the east coast, slightly above average rain and snow. Again, that should be because of that El Nino influence providing increased moisture. A key factor of the East Coast weather pattern for the upcoming winter season will be nor'easters. Nor'easters are storms that typically form off the Virginia-North Carolina coastline near Cape Hatteras and tend to ride up the East Coast. Due to the El Nino influence providing increased moisture, these storms will have a lot better chance to be bigger and stronger and cause much stronger and worse winter conditions. It will depend on how much cold air is in place, but areas of, say, Richmond, Washington, D.C., Philadelphia, New York City, Boston. These will be the areas influenced by the nor'easters, and that increased moisture could allow for a lot stronger snowstorms. Could also allow for a few ice storms as well. Washington, D.C. is very well known for ice storms. They usually have a very bad one every 5 to 7 years. It's been almost a decade since they've had one, so they are overdue, and they might be seeing one soon. To the west of this area, western New York, western Pennsylvania, and parts of Canada, average rain and snow, again, mainly due to the lake effect influence. And then looking at the slightly below average snow, and this would be areas of, say, central Pennsylvania, central New York, going into New England. This area is going to be kind of in between both influences of the lake effect to the west and the nor'easters to the east. And because those nor'easters could be further out to sea, this may cause for a slightly below average snowfall. These areas will still see a winter season, and they will probably see snow, but it may, toward the end of the season, come out to be about a little below average. I'd like to thank you all for joining us today, and I'm going to turn it back over to Dave for some final thoughts. Thank you very much.
Thanks, Jason. That was a great update. With the potential for the return of a real winter in 2013, there are some big impacts for all businesses and WeatherOps customers. During a winter storm, there are over $4.6 billion per day of economic impact in the United States alone. On average, winter storms produce more economic impact than any other weather criteria in the United States. WeatherOps has some exciting new products and services we are announcing today. And for a little over $1 an hour, you can have our expert meteorologist watching the weather for you 24/7, 365. Our team will produce daily forecast planners for your business that are key to your specific criteria, giving you a 7-day look ahead for events that can impact your operations. We come up with simple color coding of green, yellow, and red that show these impacts as you look ahead. 72 hours prior to a major winter storm outbreak, we will be producing Blizzard Watch forecast services, including twice daily emails, scheduled conference calls and webinars, and data that's integrated directly into your IMAP Pro instance with all of your other alerting criteria. If you're interested in these services or any of the other WeatherOps services, please contact Dax Cochran at 405-476-6671 or drop us an email at sales@weatherops.com, and one of our sales associates will be glad to explain all of our products and services that we offer for the upcoming winter season. Thanks for joining us this afternoon, and hope you all have a great season and stay warm.